In this video, you're going to expand your knowledge of simple linear regression. If you look at the instructions, you can see that we're going to conduct simple linear regression to predict passenger capacity of a cruise ship based on the length of the cruise ship. You can find the data in the tab marked Cruise Data. We're going to need to open up the Data Analysis Toolpack in order to run the regression analysis. You can find the option for regression towards the bottom, and then we can hit OK. We're going to need to specify the y and the x variable, and remember, it's very important that you get these correct. If you get these incorrect, all of your answers in the output will be incorrect, so pretty much everything on the tab will be incorrect. So make sure that you're really careful with this step. The y variable is the variable that you want to be able to predict. So we want to be able to predict passenger capacity. So I'm going to select that variable, and I'm going to include the heading. The x variable is the variable that you use to predict y. So it's the predictor variable, and that was the cruise length. So I'm going to select that column, including the heading. Because I included my headings, I'm going to check labels in the first row, and then I'm going to select the output range. This is where Excel should place the output. And as always with hypothesis testing, it's very important that you place the output in the designated cell. So I am going to hit OK. And then I'm going to hit OK again for that warning message. So here is the output. If you remember, we have two hypothesis tests. We have the global test, and then if the global test is significant, we move on to the individual test. So we will start with the global test. So the test is the global test. And I'm going to use the handout on isms as a guide. I always recommend using the handouts for hypothesis testing as a guide. It makes the process a lot easier. So for the global test, it's always a one-tailed right. So we can choose one-tailed right. Now for the null and the alternative hypothesis. The null hypothesis is the x variables do not significantly predict y, and the alternative is at least one of the x variables significantly predicts y. So again, the null is the x variables do not significantly predict y, and the alternative is at least one does significantly predict y. The next step is to set alpha. We are always going to use an alpha of 5% for simple linear regression. So I'm going to type in 5%. Next, we have to compute the test statistic, and that can be found in the output. So I am going to reference the test statistic, and if you remember from the previous video, this is the test statistic for the global test. And I'm going to format that to 2 decimal places. Next, we have to determine the critical values and the p-value. Excel does not provide us with critical values, it does provide us with the p-value. So a one-tailed right does not have a lower critical value. Remember, it only has an upper critical value, and we do not know that because Excel does not provide that. So I'm just going to put in a question mark. And then I'm going to reference the p-value. And it is right here. And we can format that as a percentage and show 2 decimal places. So right here, I'm just going to write a note to help you remember. This is all the information that you can find for the global test. So this is the test statistic, and this is the p-value. The next step is to determine if we are going to reject or fail to reject the null hypothesis. There are two approaches that help us make that decision, the critical value approach and the p-value approach. We can only use the p-value approach because Excel does not provide the critical values. Remember, with the p-value approach, if your p-value is less than alpha, then you reject the null hypothesis, or HO. If the p-value is greater than alpha, then you fail to reject the null hypothesis, or HO. So returning to our output, we can see that our p-value is 0, and technically it's not 0. If you carried it out to enough decimals, you would finally get a number. P-values can never actually be a true 0. But our p-value is less than our alpha of 5%. So we are going to reject the null, or HO. So I'm going to select reject. The final step is to write the conclusion. We rejected, so we're going to state H1, or the alternative, and that was at least one of the x variables significantly predicts y. So at least one of the x variables significantly predicts passenger capacity. Because we rejected the null hypothesis in the global test, we're going to move on to the individual test. Remember, you only conduct this test if you fail to reject in the global test. If we would have failed to reject, we would be done and we would not conduct the individual test. All right, step 1 and step 2 for the individual test. We're going to choose the appropriate statistical test, and it's simple linear regression, the individual test, and the individual tests are always going to be two-tailed. So we're going to choose our test, individual test, and those tests are always two-tailed. Now we have to write the null and alternative hypothesis. The null, or HO, is the slope for x is not significantly different from 0. If something is not significantly different from 0, that basically means it is 0. So the slope equals 0. That's essentially what we're saying with the null. And if you have a slope of 0, that means x does not significantly predict y. So what the null hypothesis is saying in everyday language is that x does not significantly predict y. The alternative is that the slope for x is significantly different from 0. So that means it does not equal 0. If you have a slope that does not equal 0, that means that x does significantly predict y. So in everyday language, this is what the alternative is saying. So the null is that it is not significantly different from 0, and the alternative is that the slope is significantly different from 0. Next, we're going to set an alpha of 5%. Again, for regression, we're always going to use an alpha of 5%. Next, we can determine the test statistic, which is going to be found in the output. The critical values we don't have, and then the p-value is also going to be found in the output. So the test statistic, I'm going to reference that in the output, and it is right here, t-stat for our x variable length right here, 23.56. And we do not know the critical values because Excel did not give them to us. So I'm just going to put a question mark. And then for the p-value, I'm going to reference the p-value, which is right here, p-value for our predictor or x variable. I'm going to hit enter. All right, now I'm going to format the test statistic to 2 decimal places. The p-value, percentage, 2 decimal places. And then I'm just going to write a note here that this is the test statistic, and this is our p-value, and this is for the individual test. It might just be helpful to have these notes. So for the homework, you can look at this and you can remember where everything is. The next step is to determine if we're going to reject or fail to reject the null hypothesis. Again, we can only use the p-value approach because we do not know the critical values. If our p-value is less than alpha, then we reject the null. If our p-value is greater than alpha, then we fail to reject the null. So our p-value is less than alpha. And again, it's not really 0%. If we carried out enough decimal places, we'd start to see some numbers. But our p-value is less than alpha of 5%. So we are going to reject the null. So we are going to reject the null hypothesis. Finally, we're going to write our conclusion. We rejected, so we're going to state the alternative, and that's the slope for length of the cruise ship is significantly different from 0. So X does significantly predict Y. So the slope for length is significantly different from 0. This means that length significantly predicts passenger capacity. All right, now we can complete our model summary table. So we have the intercept. Here is our intercept. This coefficient for length, this is the slope. So I'm going to reference the slope. Here's the slope. This p-value for length is asking for the p-value for the slope, which is the p-value for the individual test. So I'm going to reference that. And then I'm going to talk about standard error in just a little bit, so we'll return to that. So we can answer some of the questions. Question number 1 asks, can you use length to significantly predict passenger capacity? And that's what the individual test told us. Yes, we can. If you remember, a regression analysis does two things. First, it tells you if X can be used to predict Y, and then if so, it provides a regression equation. So that's what we're going to do now, is we're going to determine the regression equation. If you remember, the regression equation is Y hat, which is the predicted value of Y, and it is the intercept plus the slope times the X variable. So in our example, Y hat would be the predicted passenger capacity. That's what we're trying to predict. So that's what the equation is going to solve for. And then it is the intercept, which is right here, negative 20.30, plus the slope, which is right here, 4.77, times the X variable, which is length. So this is our regression equation. So a cruise ship company, all they have to do is plug in the length, and then they can predict passenger capacity. So returning to the question, we're solving for, we're trying to predict the number of passengers, so it's going to be between C, and D, and it would be C would be the correct answer. Now that we know the regression equation, now we can estimate the number of passengers. So that's what we're going to do here in the prediction table. So I'm going to reference the values from the summary table. So again, our equation is the intercept, and I'm going to lock that because that's a constant, and I'm going to copy the formula down. So it's the intercept plus the slope, and again, I'm going to lock that, times the value of the x variable, or times length. So I'm going to select length. So again, we have this formula to estimate passengers, and all we have to do is just plug in the length of a cruise ship, and then we can estimate the number of passengers. So I'm going to hit enter, and then I'm going to copy this down, and I am going to format to 2 decimal places. I'm going to check just to make sure that the references are correct. It's always good whenever you copy a formula down and you have locked references, it's always good to double check. And now I'm going to talk about the accuracy of prediction, or the accuracy of our regression equation. So the regression equation isn't perfect. It's not going to give us a perfect estimate. We're not going to be able to, with 100% accuracy, predict the number of passengers on a cruise ship given its length. There's going to be some degree of error associated with our analysis. So error, or it's often referred to as a residual, it's the difference between y and y hat. And if you remember, y hat is the predicted value of y. So it's the difference between the observed value of y and the predicted value of y. So in our example, the residual, or the error, would be the difference between what we predict passenger capacity to be and then what the passenger capacity actually is. So that would be the observed value, what it actually is or turns out to be. So here's a depiction of error on a scatter plot. So I'm returning to our example on sales calls and copiers sold. So if you remember, the regression line is the predicted values of y. So you can see that if someone made 30 sales calls, they were predicted to sell about 50 copiers. But you can see that there's some error. So you can see that this individual sold 60 copiers. So error, or the residual, is the difference between the observed value of y, or the actual number of copiers sold, which in this case is 60, and then the predicted value, which is 55. So again, error is the difference between the dots on your scatter plot, the observed values, and then the predicted y values, or the regression line. Excel provides multiple statistics that give us an idea of how big or small our error or residual is. One of the most popular measures is called the standard error of the estimate, and what it does is it provides the average difference between y and y hat, or the average difference between the observed scores and their predicted values. So the smaller this value is, the less error there is. So you want the standard error of the estimate to be as small as possible. If you return to your output, you can find the standard error of the estimate right here. So we have 4.54. And our model summary table asks for the standard error, so I'm going to reference that. So question 5 asks, what is the standard error of the estimate? So I am going to reference that from the model summary table. And then question 6 asks, on average, how much will the predicted number of passengers differ from the actual number of passengers? And that is the standard error of the estimate. So that's the definition of the standard error of the estimate. So on average, the predicted number of passengers is going to differ from the actual number of passengers by 4.55. And remember, this is in hundreds. So this is our margin of error. So we're going to be, on average, off by about 4.54 or 454 passengers. We can use the standard error of the estimate to compute what's known as the 95% prediction interval. This is an interval or range in which we are 95% confident that the actual value of y will be included in. So it's a range, so it's going to have a lower limit and an upper limit. And the lower limit is y hat, or the predicted value of y, minus 2 times the standard error. And the upper limit is y hat plus 2 times the standard error. You can see in the prediction table, we're asked to compute the prediction interval, the lower and the upper. So we'll start with the lower. So again, the formula for the lower is y hat, or the estimated value of y. So that's estimated passengers. So in our first row, that would be 13.07. And it's minus 2 times the standard error. And I'm going to reference the standard error in the summary table, and I'm going to lock it because the standard error is going to be a constant for all of our different rows. And then we can copy this down, format to 2 decimal places, and always just double check just to make your references are correct. All right, so that's our lower. Now our upper is the same thing, but it's positive instead of minus. So it is y hat, or the predicted value of y, or our predicted or estimated passengers, plus 2 times the standard error. And again, lock the standard error, it's a constant. We can copy it down, format to 2 decimal places. All right, so again, the 95% prediction interval is a range in which we're 95% confident that the actual value of y will fall in. So if we have a cruise ship that has a length of 7, we are 95% confident that the actual passenger capacity will be between 3.97 and 22.16. If a cruise ship has a length of 8, we're 95% confident that the actual number of passengers is going to be between 8.74 and 26.93. So again, our estimations, our predictions are not going to be 100% accurate. There's going to be some degree of error. So the 95% prediction interval gives us an idea of basically how big our range is. The last statistic that Excel provides that gives us an idea of error is called R-squared. R-squared is the square of the correlation coefficient. So remember Pearson's R. So if you square that, you can get an idea of how accurate your regression equation is. So R-squared tells us the percentage of the variance in y that can be explained by the variance in x. Remember, variance is just another word for differences. So it's the percentage of differences in y that can be explained by the differences in x. R-squared is a percentage, so it's going to range from 0 to 100%, and you want it to be as big as possible. You want it to be as close to 100% as possible. The bigger it is, the more accurately you can predict y. Here is our R-squared. It is 0.78 or 78%, so that's a pretty good R-squared. So we're doing a pretty good job of estimating passenger capacity. And if you scroll down here, you can see that we are asked to reference R-squared. So I'm going to reference it. All right, so what does this tell us? I'm going to format this as a percentage, show 2 decimals. I'm actually going to format this to show 2 decimals. So what is this 78% telling us? It's telling us that 78% of the differences in passenger capacity is due to the differences in ship length. So we know that different cruise ships hold different amounts of passengers. Some hold more, some hold less. Why is that? Why are there differences? Well, R-squared is telling us that 78% of the differences between cruise ships can be explained by the differences in their length. So question 4 is basically asking about R squared. This is the definition of R squared. So I am going to reference R squared.